Hey everyone, how are you? I am so sorry that the weather caused me not to be able to meet you and be with you here today. This is me, this is Miss Lang. This is my fiance Joe, and this is a picture of me just so I could say hello, and I'm really looking forward to seeing you soon. Today we're going to be just kind of starting out with topic 1, especially because we've had all these snow days. We're going to need to catch up a little bit, but I won't push too hard. We'll go at a normal pace, but that means that instead of like a getting to know you thing, especially since I'm not here, I figured we would just like start and get to work, and we'll start with this topic 1, okay? So I'll talk to you all about the assignment sheet, which you'll get when I meet you, and the syllabus and stuff like that when I'm there. But today we'll just jump in and just kind of talk about graphing some categorical data, okay? Anyway, thanks for being real patient, and again, please know how sorry I am that I'm not here. Okay, so just anything I write on here, you just write on your paper, okay? Okay, so today we're going to be first of all, looking at the difference between categorical versus numerical data, okay? Categorical variables are where the outcomes fall into categories. So when I say they fall into categories, it's basically something that like you can kind of describe what happened. So I'll put like description here, okay? One categorical variable we'll be dealing with a lot in chapter 2 is like a win versus a loss, okay? Another one would be a make versus a miss. In school, like you could be categorized as a junior or a senior or a freshman or a sophomore. Colors are things that are categorical variables because they can be described as things like green and white or maize and blue. Okay? Now, numerical variables are where the outcomes represent numerical quantities. Now, just because it's a number doesn't mean it's a numerical variable. To be a numerical variable, the number has to be measuring something and not describing something. So numerical variables are where we have a measurement. So examples would be something like the distance that a ball is hit, because that can be measured. The number of 3-point shots that go in could be numerical because that's something that you can measure and count. The height of a hockey player, the batting average is something that measures how good a player is. Win percentage, something that kind of measures how good a team is. So again, numerical variables are things that you can basically measure. So the number represents either a count or a measure, okay? So let's determine whether the following variables are categorical or numerical. Weight of a wrestler. Is weight a description or a measurement? Well, weight is more of a measurement, so weight is going to be numerical because notice that you're measuring pounds. Is usually how we measure things in the human body. So the weight of a wrestler is numerical because we are measuring pounds. The color of Major League Baseball uniforms. Well, we're not measuring that. That's more of a description. So that would be categorical because we're describing the color. How about letter C, zip codes? zip codes are numerical, but are they like, okay, zip codes are numbers, let me put it that way, but do those numbers measure something, or do those numbers describe something? Zip codes don't measure anything. So even though zip codes themselves are numbers, zip codes for NBA teams would be categorical, okay? So I don't know if you need to make a little note that these numbers do not measure. Okay, so just because something is a number doesn't mean it's numerical. It has to measure something. So this zip code would be categorical because, again, the zip code would kind of describe the area in which they live. Okay? We are going to be focusing on categorical variables for chapters 1, 2, and 3, essentially. And the first thing we're going to do today is look at data displays for categorical variables. So here are some things that we'll do in all of these data displays that we talk about today. The first thing you're going to do is you're going to be given information, and we need to divide so that you turn it into a percent. Okay? What I'd like us to do is round to the nearest tenth of a percent, which is 3 decimal places. So let's say that we divide in our calculator the successes divided by the total, which we'll practice in a sec, and we get 0.0817. So we get other values also. So what that means is that this would be like rounding to 0.082, again, to 3 decimal places. We look to the right, the 7 says to round that up to 0.082. And then we either multiply by 100, or then we move the decimal over 2 places to the right, and that tells us that that would be 8.2%. So that's the rounding that we'll be doing for our percentages today. And, so that makes sense that you would do that in the homework also. Okay. So these are ways that we're going to display categorical variables. There are 3 ways that we'll talk about. The first one is a pie chart. In a pie chart, you're going to have 2 circles. You can see this one here. In a pie chart, we're going to have 2 circles, and each circle represents 100%. And each circle represents a particular context. For example, the context could be what happens at home, what happens away, what happens during the regular season versus the playoffs, what happens when you shoot right-handed versus left-handed. So that's what I mean by context. In the pie chart, we want it to visually be so that each piece is proportional to the frequency of the outcome. What that means is that if you saw a pie chart with this, half the circle is shaded in, so that would imply that it happened half the time. You wouldn't want to shade half if that was only like 10%. So that's what that means here. Okay? When we are drawing these, just remember that if we have a full circle, that like 50% would be half of it, 25% would be a quarter of it, and then we can go from there. And it's called a pie chart because we divide it like pieces in a pie. All right. So here's the example. This is just one example. We're going to be graphing 3 different ways today. This example says, after the LA Dodgers acquired Manny Ramirez in the middle of the 2008 season, he had 17 home runs in 187 at-bats during the regular season. During the playoffs, he had 4 home runs in 25 at-bats. Let's organize this data in a pie chart. So in order to do that, again, we want to turn the data into percentages by dividing. So notice that we have some information about the regular season. So let's calculate, let's calculate that over here. So in the regular season, let's look at his successes, okay? So his successes were that he had 17 home runs in a total of 187 at-bats. So that means that we would take 17 divided by that 187. Okay? And let's turn that into a percentage. So 17 divided by 187 gives us 0.090909, blah, blah, blah. Okay? So we want to round to the nearest tenth of a percent, which is 3 decimal places. So 1, 2, 3 decimal places is that 0. What does the 9 tell me to do to the 0? It tells us to round it up to 0.091. So let's make a note of that here. That 17 over 187 gives us 0.091. And that means that that would be 9.1%. So we would move it over 2 decimal places, and we'd get that we have a success of 9.1%. Okay? Let's leave a little bit of space, and let's also look to see what happened in the other context. The other context was in the playoffs. In the playoffs, there were 4 home runs in 25 at-bats. So let's take a look at the playoffs. Okay? That means that in the playoffs, the successes, there were 4 home runs out of 25 total. So we would again divide 4, 4 divided by 25. And we don't have to really round it all there, do we? It just makes 0.16. So that equals 0.16, which means that that would be 16%. Okay? So we said, so that's the first thing. We want to do that calculation. Now we're going to put this information in the pie chart. Remember that each circle is 100% and represents a context. These are the 2 contexts. One context is our regular season. Another context is the playoffs. And now we are going to differentiate between the regular season and playoffs by the data we have. So in the regular season, it said that we had about 9.1%. So I'm just going to find the middle of the circle, and I'm going to draw a radius out to any point. You could start this anywhere. I'll just start it right here. And then we're going to draw a line segment, another radius, to block off 9.1%. We'll think this would be about 25%, right? About a quarter of the circle from here to here. So half of 25% would be 12.5%. So that means that 9.1% is going to be smaller than that. So I'm going to estimate that this is about 9.1%. Now, let's say that I pulled someone in from the room and asked them what percentage is that. Would they have any idea? I wouldn't. So what we want to do is we want to make sure to label that with the appropriate percentage. So let's tell people that it is indeed 9.1%. Now, that being said, we said that this whole circle is 100%. So if this little part was 9.1%, what's this other portion going to be? So to get the not success, which in this case is not a home run, I should have labeled that better. you're going to take the 100% minus the 9.1%. I'll show you what that looks like. 100% minus 9.1 gives us 90.9%. So let's not make other people have to subtract. Let's label this other part with 90.9%. And you could put that anywhere in that piece of the pie. Okay? So if we did that for the regular season, let's do the same thing with the playoffs. And for the playoffs, we want to block off a 16% piece. So I'm going to try to find the middle. And again, I'll just start here. And again, this was 25. This was 12.5. So 16% is going to be more than 12.5%. So I'll make it maybe like here. And I won't get too upset if we're off a little bit, but if you tell me that 16% is like from here to here, that's a problem because that's way too big. But just kind of use those as some ballparks when you're drawing. Okay. Once again, we wouldn't know that this is 16% unless we label it. So let's label this 16%. And then let's take 100 minus 16% to find the other portion, which is going to be 84%. So we have most of this labeled very nicely, except again, if we didn't have this information over here, would you know which were the successes and which were the failures, or what this even represents? We wouldn't. So what we're going to need is we're going to need a little bit of a key. And so what we'll do is to the side, we'll have a little key where, and you can just shade it. I'll use some colors. But basically where we're going to shade our successes, which in this case represented a home run versus not a home run. So I'll just label those different pieces. And I can choose a color to do for home run. And then I could shade the portion that was the home run. Okay. I like color, so I'm going to get another color out and do the not home runs. I don't know if on the video you guys will be able to differentiate between the colors. I know that this isn't the greatest quality recording, I'm sorry. Okay. But essentially now that looks like a pretty good pie chart, except for one thing. Yes, we know that this is regular season and this is playoffs. And because of this key, we know that in the regular season it was 9.1% home runs, 90.9% not home runs, 16% home runs in the playoffs, 84% not home runs in the playoffs. So what's the problem? Okay, the problem is we don't know who this is. So we look back in the body of the problem, and it says that this is Manny Ramirez. And to be honest, the name isn't enough. If any of you are athletes or musicians or artists, we sometimes don't perform the same from year to year, or from concert to concert, or from drawing to drawing. So what we should do is we should date this. And so this was in the 2008 season. And so this is a beautiful pie chart. And I like to happy cloud my answers. That's not a very nice happy cloud. But anyway, but this is everything that your chart should have in it. Notice that we have percentages labeled, we have the context labeled, we have the category outcomes labeled, and we have a title. Now before you flip it over, one last thing is that notice that this asks us to describe what we see. And these are different performances. And because we're looking at the home runs, we can visually see where the performance was better or worse. And so what we notice is that the playoffs had a larger percentage of home runs than in the regular season. So what we'll say here, put it over here, is when it says describe what you see, we'll say Ramirez performed better in the regular season. Oh, just kidding. In the playoffs than in the regular season. And that would be a nice describe what you see. What sometimes people will say is that they'll say Ramirez had more home runs in the playoffs than the regular season. And that's bad because technically he didn't have more home runs in the playoffs, right? Technically the number of home runs was more in the regular season than it was in the playoffs. But proportionally, that's what's really important. And so we wouldn't want to say that he had more home runs in the playoffs than in the regular season because that's not true. And we wouldn't want to say that even though it is true, that he had more home runs in the regular season than in the playoffs because they don't have the same amount of attempts, which is why we turn everything into percents and why this statement comparing the performances, describing what we see, has to deal with the percentages and not the actual numbers. Okay? Of course, you also could have said that he performed worse in the regular season than in the playoffs too. Okay? So that's a little bit about the pie chart. So now let's flip and let's talk about the segmented bar chart. Okay? So like the pie chart, each rectangle totals 100%, but instead it's rectangular instead of circular. Okay? So the segmented bar chart is like the pie chart, oh my gosh, I can't spell today, but is rectangular. And each rectangle then is going to total 100%. Just like the pie chart, each piece that you draw is going to be proportional to the frequency of the outcome. So if you see more of one thing in the picture, that means that the proportion was more. And to make sure that happens, we want to make sure that the bars have the same width. Okay. Let's make the percentage the vertical axis. Okay. And then the key is going to be your outcome, which are the two categories that we have. Okay? So oftentimes the categories we'll deal with are like success and failure. Okay? So instead of having to calculate all that stuff again, I'm going to use the same example. And this time we're just going to look to see what a segmented bar chart would look like. So in a segmented bar chart, what we would need to do is we would need two large rectangles to total 100%. So let's look at this axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 boxes going up. If I went by 10%, then that means I could total 100. So let's count by tens. Let's label this axis as the percent axis. And you don't have to label every 10. You can if you want. But just enough so that people will be able to read your scale and will be able to know what the scale is. Okay? So again, then we need two large rectangles. So I don't usually like to start on the axis. I like to leave a little space. So I'm going to have one large rectangle. And notice that I happen to make this rectangle with a width of 6. So that means that my other rectangle has to have a width of 6 also. So you want to start with 2 congruent rectangles. Just like on the other side, we really started with 2 congruent circles, but I drew those for you because I can't draw circles. Okay. All right. So now that we have those 2 rectangles, again, remember that each one is going to represent a context, just like the circles did. And our contexts here are the regular season and the playoffs. And this time, it's a little easier for us to separate this because we know that each box is worth 10. So if in the regular season we had 9.1% home runs, that 9.1% is going to be just below 10. Okay. And in the playoffs, if the success was 16%, here's 10, 20. So 16 is going to be just above the middle. So what are some problems with this? Well, again, we don't know what these numbers are, so we should label with the percentages. So 9.1 was the percentage in the regular season, which means that we had 90.9% left. In the playoffs, we had 16%, and then 84% that was left. And then once again, we just need to know what these different portions represent. So what we could do is say that this represents a home run. This represents not a home run. And we can shade accordingly. I'll use the same colors. So our home run is here. And you want to put the categories, because again, the key is the outcome or the different categories that we had. The categories were home run or not home run. You want, it doesn't matter if they're on the top or bottom, but you want to make sure that they're next to each other so that it's easy to compare and see which one is better or worse. Okay? And then I'll do the same with the not home run. And the only other thing that's missing is our title. Again, this is the same data. So this is just Manny Ramirez in 2008. And there's our very nice segmented bar chart. It's called a segmented bar chart because the rectangle is broken up into 2 different segments each, okay? Segmented bar chart is my favorite, hint, hint. And yeah, so this one was faster just because we had the percentages already, but also because we didn't have to think too much about where to divide the circle because our grid really helped us with that. Notice this also says to describe what you see. And once again, visually, we see that there's a larger percentage of home runs in the playoffs than in the regular season, which means that we can say, oops, that Ramirez performed better. We'll talk about performance in the next few days. Ramirez performed better in the playoffs, I got it right this time, than in the regular season. And again, the performance was better, we see, because there was a larger proportion of home runs in the playoffs than in the regular season. Okay? So the bar chart is the last one. This one is grouped differently. These were so similar to each other. These were both regular season and playoffs. The key was both home run, not home run. We saw the same type of a thing. The bar chart is a little bit different, okay? This time in the bar chart, it's grouped by the categories. So that means that the clumps, I'll talk about that in a second, will not total 100%. The clumps, okay? Each context will still total 100, but the categories, when they're clumped together, don't make 100%. Once again, each piece is proportional to the frequency of the outcome. Again, so that means that if something has more shading than the other, then that means that it happened more often. And again, to facilitate that, we'll make sure that the bars have the same width. Once again, the percentage will be the vertical axis, but this time the key is the context, okay? So the different places or the different times that the things were going to occur, okay? So again, this is different than the others. So I have the same example, and so I'll just kind of darken my axes here. Let's do the same thing and go by tens as far as our percentages on this vertical axis. Oops, sorry. We'll go by tens on the vertical axis. But then again, the thing is that the groups are by category. So instead of regular season and playoffs, we're going to group as home run and not home run. That's what I mean by that they're clumped differently. So for home run, we had two different places where we had home runs. So that means that we're going to need two different rectangles by those home runs. So one of them was the regular season with 9.1%. So what I'll do is I'll just make a little rectangle at about 9.1%. And there was also 16%. So I'm going to make another rectangle by the home runs at about 16%. So this tells us that when we talk about home runs, there were two different places that that could happen. Again, that's very hard to read, so we should label with the percentages, 9.1% and 16%. This is what I mean by the clumps will not total 100%. Notice these don't total 100%. But when we talk about not home runs, we know that if 9.1% were home runs, then we knew that 90.9% were not home runs. So that's going to go over here. So I need to draw a rectangle all the way up to 90.9. So just above 90. And then I also had not home runs at 84%. So 10, 20, 30, 40, 50, 60, 70, 80, a little less than halfway here. So these were two situations where we did not have home runs. In one situation, we had not home runs 90.9% of the time, and the other time, 84%. So that's what I mean by the clumps will not total 100%. These two clumped together don't make 100. These two clumped together don't make 100. That's what I mean by that, okay? So that means that our key, we said, is the context. Our key is going to be, what are the two different places where we had home runs and not home runs? Well, one place was the regular season, and the other place was the playoffs. Okay. And, I don't know, I'll just, again, just pick the first one as my blue. So the regular season would be this 9.1% and this 90.9% make up our regular season. And this 16% and 84% make up our playoffs. Okay? So, and the reason that they do that, that they clump it this way, is because really we want to compare the home runs to each other. So notice in the segmented bar chart, the home runs in the two contexts were next to each other, regular season versus playoffs. Notice in this bar chart, the same thing. The home runs are right next to each other, regular season versus playoffs, so that it's easy to compare. We need a title. So this is going to be Manny Ramirez again, still in 2008. And this is what a nice bar chart looks like. So yes, the regular season totals 100. The playoffs total 100. But each clump of home run, not home run, together don't total 100. And again, describe what you see. We'll say that he performed worse this time. How does that sound? So we can say that Ramirez performed worse in the in the regular season than in the playoffs. You could have written the exact same sentence that we wrote for the other two examples. That also would have been A-okay. Okay? Oops, let me read that. All right. And that's the gist, okay? So thank you for being patient while I'm out. There's homework that I'll check in with this when I get back. Just make sure that your graphs look like this, that you're dividing the successes divided by the total, and hopefully you should be good, okay? I look forward to meeting you. Have a great day. Bye.